All right, hello guys. This is lesson 116. We're going to be talking about the fundamental counting principle and permutations, which is, in my opinion, one of the more fun things in math. So if we take the letters A, B, and C, write them here, A, B, and C. And we're going to say we're going to arrange these letters in as many ways as possible. So we can have A first, and then B, and then C. Or we can have C, and then B. We can have B first, A, and then C. Or C, and then A. And we can have C first. A, B, or B, A. So there are 6 different ways that we can combine these 3 letters. And these are called permutations. Each different order is called a permutation. So we can say, we can make a little box diagram. There's 3 letters, right? So we can put any one of the 3 letters in the first box. Now, we're not repeating any letters, so if we put 1 letter in the first box, we only have 2 letters left, so there's 2 possibilities for the second box. And in the last one, we only have 1 letter left, so that's 1. Now, how we find out how many permutations we can get, we just multiply all these numbers. So 3 times 2 times 1 is going to give us 6. 1, 2, 3, 4, 5, 6. 6 possibilities. Now, if the permutation, if repetition is allowed, then it's going to be a little bit different. We still only have 3 letters, so we only have 3 boxes. But if repetition is allowed, then there's 3 possibilities for the first box, 3 for the second, 3 for the third, which means there are 27 possibilities to arrange these 3 letters. So, let's do some problems. All right, so how many different ways can the numbers 3, 5, 7, and 8 be arranged if no repetition is permitted? All right, so this is going to look a little bit like the first arrangement we did of the letters. So we have 4 numbers, so we're going to have 4 boxes. Those aren't very even boxes, that's okay. All right, so there's no repetition permitted, and there are 4 numbers. So there are 4 possibilities for the first box. 3, 2, 1. All right, kind of seeing a pattern? All right, so then we'll multiply these out. So you get 4 times 3 is 12, times 2 is 24, times 1 is 24. So there are 24 ways that we can arrange these 4 numbers without any repetition. Let's try another one, this time with letters again. All right, so how many 4-letter signs can be made from the letters in the word equal if repetition is permitted? All right, so here we are told that it has to be 4 letters in the sign. So that means we're going to have 4 boxes. All right, and we have 1, 2, 3, 4, 5 letters. All right, repetition is permitted. So we have 5 possibilities for the first letter, 5 for the second, 5 for the third, 5 for the fourth. So that is going to give us 625 different signs. All right, now we're going to talk about probability. And this is the study of outcomes that have an equal chance of occurrence. So with probability, we're usually going to be talking about flipping coins and rolling dice. So if you flip a coin, you have 2 possibilities. You either get heads or tails. Those are your possibilities. So the probability of getting heads you can write it like this, is going to be the number of occurrences over the number of outcomes. So I guess we could write it like this. So the occurrence of heads is 1, and the total number of outcomes is 2. So the probability of getting heads is going to be 1 out of 2. All right, and then when we roll a dice, we have 6 possibilities. So here you have the 6 possibilities when you roll a dice. So you have the number of occurrences, which can be, what's the possibility of rolling a 3? So 1 occurrence, 6 outcomes. So you have a 1 in 6 chance probability of rolling a 3. So what happens if you roll 2 dice? If you roll 2 dice and you're looking for the probability of getting a number, you're going to have even more possible outcomes. So you have the 1 through 6 of the first dice and the 1 through 6 of the second dice. So you have all these possible outcomes. So the probability of rolling, for example, a 7 is going to be the number of 7s you can get and the number of outcomes, which in this case we got 1, 2, 3, 4, 5, 6 possible chances of getting a 7 out of 36 total outcomes, which gives us a 1 in 6 chance probability of rolling 7. Now, we can also talk about coin tosses. Like we talked about earlier, we can either get heads or tails. Now, this is an independent event. So, if we have, what are the possibilities of getting heads every time with 3 coin tosses? So, we can write, there's the 1 out of 2 possibility in the first time, 1 out of 2 the second time, 1 out of 2 the third time. So to get heads 3 times in a row is going to be a 1 in 8 possibility. Now, if we say, what are the possibilities of flipping heads 3 times and then the possibility of flipping tails the 4th time? Since this is an independent event, it doesn't matter what happens before, so therefore it's still just going to be 1 out of 2 chance of getting tails on that 4th